Relationships between frequency and time period. We know that the frequency is denoted by f, and which is defined as 1 by time period. It means frequency is inversely related to time period. Now we will see how it is so. So the time period for a wave, if we draw a wave, the time period is the length of the wave, which is called a wavelength, lambda. Lambda is the wavelength. Now, the time taken for this complete wave, for this one wave, is called T, time period. So, the time period T is basically the time required to produce the complete wave. T is time period, and which is defined as time required to produce a complete wave. Let us take, for example, the time period of the wave is t seconds. That is, in this figure, the time period of the wave is t seconds. That means to produce a wave of 1 lambda, the time period is t seconds. It means that in t seconds, you have 1 wave produced. So, in t seconds, if 1 wave is produced, we also have one more definition. The number of waves in 1 second. What is it? It is frequency. So, the frequency f is number of waves in 1 second. Now, we have in t seconds 1 wave is produced. F is number of waves in 1 second. So, from this we can understand that f, the frequency, is inversely proportional to the time. So, for 1 wave, it takes t seconds. Then we can define f as 1 by t. So, the frequency is inversely proportional to the time period of the wave. If time period is less, then frequency will be higher. If time period is more, then the frequency is lesser. So, we say that frequency of a wave is inversely proportional to the time period of the wave. Having known the relationship between t and f, let us see the relation between v, velocity, f, frequency, and lambda, wavelength. So, let us take a wave and whose wavelength is lambda and the time period is t, and the wave is traveling with a velocity v. V is the velocity and f is the frequency of the wave. That is, number of waves in 1 second is f. Now we know from this v is velocity of the wave and f is frequency of the wave and t is time period of the wave and lambda is wavelength of the wave. Now we know the basic definition of velocity. V is distance travelled by time taken. This is the definition. We take it from motion. In this case, the distance travelled for the wave in time period t is lambda by time taken is t. And we also know that 1 by t is frequency f. So this can be written as lambda into 1 by t, which is lambda into f, or f into lambda. Therefore, velocity v is equal to f into lambda. That is, velocity is a product of frequency and wavelength of the wave, which is called a wave equation. And this wave equation is applicable to all types of waves, transverse as well as longitudinal wave. So this wave equation is velocity is a product of frequency into lambda, and where velocity is in meters per second and lambda is in meters and f is in hertz. Units for v, f and lambda is this. And using this equation, if we know two quantities, we can find the third quantity.